Hello friends, welcome back. In this session, let's look at limits at infinity and also infinite limits. So let's take a simple example to understand how to solve the problems when either the limits are tending to infinity or for the infinite limits. So let's take this example. We have the example here. I have been given find out the limit as x tends to 4 x square plus 5x plus 6 divided by x square minus 8x plus 16. Now, if I try to substitute the value of x equal to 4, what I will get? Before that, I'll just see whether I can factorize this so that it will be easy to substitute the value. I can write it as x square plus 5x plus 6. I can write it as x plus 2 into x plus 3 divided by x square minus 8x plus 16, that is nothing but equal to x minus 4 into x minus 4 or x minus 4 whole square. Now if you substitute the value of 4, you will get 6 into 7 divided by 0 into 0, so which is not defined. So how to solve the limits like this? That is what we are going to learn this particular session. Okay. To understand that, what we will do, we'll step back a little bit from this particular problem and try to take some simple examples to understand how to deal with this particular problem. Okay, right. So for that I will take two examples. We will plot two simple graphs. One is y equal to x or f of x equal to x. Another one, f of x is nothing but equal to 1 by x. So what I am trying to do now, I am taking two graphs, two functions we are trying to plot. One is y equal to x and the another is y equal to 1 by x. And can you observe that if this is f of x, then this is 1 by f of x. So you can start thinking that we are talking about if f of x behaves in one such a way, then how 1 by f of x will behave. So if f of x is behaving in a way, then how 1 by f of x will behave. That is what we are trying to see now. So that's why I have taken y equal to x and y equal to 1 by x. Now let us just try to approximately plot this and see how the graph looks like. Now y equal to x, if I plot that, if I say x equal to 1, y equal to 1. If I say x equal to 10, y equal to 10. If I say x equal to 100, y equal to 100. If I say x equal to 1000, y equal to 1000. Let me take negative values. If I say x equal to negative 10, y equal to negative 10. If I say x equal to negative 1, y equal to negative 1. If I say x equal to negative 100, y equal to negative 100. So let's just try to plot this. This is very simple line. If you know a little bit of coordinate geometry, this is nothing but y equal to x is a straight line with the slope 1 or making an angle 45 degrees with the positive direction of x-axis, and you have both x coordinate, y coordinate equal. So it will be nothing but exactly bisecting your x coordinate and y coordinate axis. So it will be like this. So that is how the graph goes. If I just try to plot that approximately, the graph will be going like that. That means if as x value is increasing, y value is also increasing. Similarly, if the x value is decreasing, x value is decreasing, y value is also decreasing. What is the meaning of that? What is the meaning of that? Suppose let us say x equal to 10 to the power of 6. So y value also is equal to 10 power 6. Let us say x equal to very big value, then y is also equal to that particular big value. So what we are trying to say now with that, we are saying that if x is tending to infinity, y also tends to infinity. Similarly, here you can say if x tends to negative infinity, this is where you have negative infinity, negatively large number, then y also tends to negative infinity. What else I can say? I can also say that if x is moving towards 0, if x is tending towards 0, if x is tending towards 0, then y tends to 0. If you either come from left direction or you come from the right direction, in both the directions, x tends to 0, then y tends to 0. So that is the graph of y equal to x. Now let us see y equal to 1 by x and see how it behaves. Okay. So what I will try to do now is I will try to plot y equal to 1 by x. So let me take some values for y equal to 1 by x also. I will say x equal to 1, y equal to 1, perfect. If x equal to minus 1, y is equal to minus 1. If x equal to 10, y equal to 1 by 10. If x equal to 1 by 10, y equal to 10. If x equal to 100, y equal to 1 by 100. If x equal to 1 by 100, y equal to 100. So let us see how this graph looks like. Similarly, okay, so let me try to plot that approximately so that we can see how the graph looks like. Now one thing I know, if x equal to 1, y equal to 1, so that is where it will be. Similarly, f equal to x equal to minus 1, y also will be equal to minus 1, that point I know. Now let us say if x equal to 10, if x equal to 10, somewhere here y is equal to 1 by 10, so the point will be like that. If x equal to 100, if I go somewhere, let us say that is 100, so y is nothing but equal to y by 1 by 100. That means you can see that as x value is going on increasing, y value is going on decreasing. Why? Because if you take x as very big value, when you divide it by 1, it will automatically become a very small value. So that's a simple common sense what we can understand. Okay. Similarly, if you see on the negative side also, if x is becoming more and more on the negative side, let us say x equal to minus 100, you can see that y equal to minus of 1 by 100. That means it's almost like as x is tending to bigger and bigger values, y is tending to 0. Similarly, if x is, let us say, smaller value, like x equal to 1 by, let us say x equal to 1 by 10. If x equal to 1 by 10, that means this is 1. So let us say 1 by 10. You can see that y value is nothing but equal to 10. If x equal to 1 by 10, y equal to 10. Similarly, if x equal to minus 1 by 10, y equal to 10. If x equal to, let us say 1 by 100, y will be equal to somewhere there. But you can see that similarly, as x is going on increasing in positive direction, y is moving towards a positive. If x is going on positive direction, nearing towards the origin, that means x is becoming small and small, you see that y is becoming more bigger and bigger. If x is in positive, then y is moving towards a positively big value. If x is becoming negatively small number, then y is becoming negatively big number. So what are our observations? Let's try to write them down here. The first observation I have, let me just plot this before that, so that we can have a look at the graph, how it looks like. So the graph will be something like this. It's an approximate graph. I'm just doing that only for our understanding. Okay. So it will be something like that. Oops. But I think it will go like that. And here also it will go. It will not touch the x-axis, but it will be going in that direction. Similarly here, if you are able to see, we may have something like you can see that. Now, what are our observations? Let's try to put down. Once we are able to put down the observations, then you can see why we are learning this to solve a particular problem what we are looking into. Now what you can say about as x is moving towards positive infinity, that means x is moving towards more and more bigger value, you can see that y is moving towards 0. Similarly, if x is moving towards negatively larger value, very larger value, negative infinity, you can see that again y is moving towards 0. Not only that, if x is moving towards 0 and you are in the positive deleted neighborhood, what is the meaning of that? We are looking into the values, the set where you are near to, or can I say you are coming from right hand side, you are coming from positive values and you are approaching to 0, or you are coming from right hand side, or if you are in deleted neighborhood of positive, then you can see that y is tending towards infinity. Similarly, if x is tending towards 0 from negative side, you can see that y is tending towards negative infinity. Now let us put down all our observations. Let's put down all our observations and see what's happening now. Okay, let me take one by one. Okay, if you can see that if x is tending to 0, then y is tending to 0. This is with respect to f of x. But with respect to 1 by f of x, if x is tending to 0, y is tending to infinity. Okay, understand that. Similarly, if x is tending to infinity, y is tending to infinity in f of x, whereas in 1 by f of x, if x is tending to infinity, y is tending to 0. Now what is the meaning of that? The meaning of that, whatever the observations we have found, if you are able to understand, we can summarize them in three simple rules or laws. What we can say is, first one, if limit of x tends to a particular value a, f of x is tending to infinity, then, or can I say directly equal to instead of f of x equal to infinity, that implies that limit x tends to a, 1 by f of x tends to 0 or equal to 0. Similarly, if limit of a function as x tends to a, 1 by f of x is equal to, or let me take it in the reverse way, let us say f of x is equal to 0, then f of x equal to infinity, then x tends to a, 1 by f of x will be equal to 0. If limit x tends to a, f of x equal to 0 and you are in positive or you are in negative, deleted neighborhood you have to look into. If you are in positive, then 1 by f of x will be equal to positive infinity. If you are in negative, 1 by f of x will be equal to negative infinity. This is nothing but limit x tends to a. Limit x tends to a. I'll just try to summarize this. This is important. So what we are saying now is, if you have a function which you cannot solve it, there is one option for you. If you know that f of x is equal to infinity, or it's approaching towards infinity, you cannot solve it, then reverse it, take 1 by f of x. If f of x is going to infinity, then 1 by f of x will go to 0. Now you cannot solve f of x, then reverse it 1 by f of x and find it out. If 1 by f of x is equal to 0, then f of x will be nothing but equal to infinity. So let me summarize that, what we have observed from these two graphs, whatever we have seen that if x tends to a particular value, f of x is tending to infinity, then 1 by f of x tends to 0. If x tends to 0, f of x is tending to 0. When you look at 1 by f of x, it will go to positive infinity if x values are in positive deleted neighborhood. It goes to negative infinity if x is there in the negative deleted neighborhood. That's nothing but we summarize it here with two simple, or can I say 1, 2, 3, 4. Let us look at that. If limit x tends to a, f of x is infinity or f of x is negative infinity, then x tends to a, 1 by f of x is equal to 0. Can you see that? X tends to a, f of x is infinity or negative infinity, 1 by f of x will tend to 0. We can see that with respect to the example whatever we have taken. Also, if limit x tends to a, f of x is 0, you are in positive neighborhood, then 1 by f of x will tend to infinity. If x is in the deleted neighborhood of negative values, then f of x will, 1 by f of x will tend to negative infinity. So we can leverage this particular rule. You can just go through that. This is very important to understand. For that we have taken this simple example. You can do that again. You can take f of x equal to y equal to x, and you can take 1 by f of x is nothing but 1 by x. You can ask me why you have taken y equal to x, y equal to 1 by x. Why not any another example? I can take y equal to x to the power of 4, and I can take y equal to 1 by x to the power of 4, or for that matter I can take the same example what we are looking here, like x square plus 5x plus 6 by x square minus 8x plus 16. I can take this as f of x, and I can show you 1 by f of x is moving towards 0 as x tends to 4. Then I can come back and say that therefore f of x should tend to infinity. That is what we are going to do now. I hope you are okay, comfortable with that. So let's go ahead and solve this problem. Now how to solve this problem? As we have discussed, let me just try to erase this so that we can go ahead with the problem. Okay, to solve this problem what we will do, we will take, suppose this is f of x, we will take what is 1 by f of x. 1 by f of x is nothing but x square minus 8x plus 16 divided by x square plus 5x plus 6. Now what we will do, we will check the limit of this. As x tends to 4, what is the value of this? X square minus 8x plus 16 by x square plus 5x plus 6, which you know is nothing but equal to x minus 4 whole square divided by x plus 2 into x plus 3. I have to say again, limit x tends to 4. Now if you substitute 4 there, you will get 0 divided by some value. Let us say it's nothing but 6 into 7, 42, 0 by 42, which is nothing but equal to 0. Now I will use the rule what I learned just now, and I will say that okay, now I know that 1 by f of x is equal to 0. So I know that limit x tends to 4, f of x, that is nothing but equal to whatever I have to find out, that is x square plus 5x plus 6 divided by x square minus 8x plus 16 is nothing but equal to infinity. This is where we have used the rule limit x tends to a, f of x, 1 by f of x equal to 0, then f of x equal to infinity. If limit x tends to a, 1 by f of x equal to 0, then x tends to a, f of x equal to infinity. So whenever you see problems like this, which you cannot solve by rationalization or factorization, but you see that by substituting the value in denominator, you are making it as 0, which cannot be solved. What we can do is, we can reverse the function and we can apply this particular rule that if f of x is not defined at x equal to 4, I I can reverse that and I can find out that 1 by f of x limit is 0. So I can go back and say f of x will tend now to infinity. So in the next session we will look at examples where as x tends to infinity, not a particular value, but x tends to infinity, how to solve the problems where the function, algebraic functions we are talking about, that cannot be rationalized or factorized, but we want to find out the value as x tends to infinity or limits at infinity. I'll catch you in the next session. Thanks for your time. Bye for now.